In this video, we're going to go through properties of ionic compounds. So the first property deals with melting and boiling points. Ionic compounds are held together with very strong attractive forces. So the cations and anions are held really tightly together. So to move these ions out of their current state, it takes a lot of energy or a lot of heat for this to happen. Because they have really high melting points, ionic compounds are solids at room temperature. The next property is that they are soluble in water. Soluble just means dissolve. Now, water molecules are polar, and if you think about the Earth, we have a north and south pole. They're different. So water molecules are polar, so they have a positive side and a negative side. So they are different sides. Okay, now I know this looks absolutely terrible. Just hold on for a second. So down at the bottom, we have our ionic compound, which, if you notice on our ionic compound, it alternates positive, negative, positive, negative. Okay. Now the water molecules, H2O, our water molecule here, the oxygen, has a negative charge, and our ionic compound, positive, negative, we've got a positive right here. These two line up, and there's an attraction that occurs between the cation and the negative pole of our water molecule. So because there is this strong attraction, ionic compounds will dissolve or break apart in water. As solids, ionic compounds are not conductive, but when we dissolve them in water, they are conductive. So electricity is conducted when charges move from one place to another. In the solid state, if you go back and look at our structure here, it's tightly packed. They can't move. When they can't move, it's not conductive. When it's dissolved in water, however, that ionic compound breaks apart, and now the ions are free to move. So it is conductive. So again, solid doesn't move. As a liquid, it is, or when dissolved in liquid, those ions are free to move. And now electricity can be conducted. Next is the crystalline structure. So ions are arranged in a repeating pattern, as we've already seen. It goes positive, negative, and so forth. So it lines up into this really neat structure. So if you've looked at salt really close, it kind of looks like a crystal. Under a microscope, you can see it a little bit better here. So it's not clear from the picture on the left, but if we were to zoom in even further, we would notice that the cations and anions alternate in this nice crystal structure, and it's so satisfying. Okay, so crystalline structure is the other property. Finally, brittle. Applying pressure to our crystalline structure shifts the alignment of the ions, which results in the repulsion of charges. This causes the compound to fracture. Okay, so looking at the diagram on the left, you notice it alternates positive, negative, positive, negative. Opposites attract, so it's held together really tight. So if I took this whole section right here and applied a force, it would shift the entire section down, and we would end up with this. Now positives are next to each other, negatives are next to each other, so they are going to repulse, or they're going to push off of each other, and it's going to fracture our compound. So that is why ionic compounds are brittle.